Good morning, wonderful, amazing, fantastic geometry students. This is Nish Youngblood. Hoping this video is finding you well. I hope that you guys are staying safe, healthy. I hope that you are aware of the resources that are available to you guys through the district and the community. If not, just let me know and I will make sure I'm able to communicate those resources that have been shared with us to you all. But the topic for review for today in geometry is the midpoint and distance formula. So for those who have been keeping up with the enrichment assignments, let's look at the assignment that I posted on Google Classroom first. So the front half of the assignment is just using the midpoint formula. So we're going to review 2 problems from the front and 2 from the back, which has the distance formula. So on this first problem, we're looking at problem 4 on the assignment posted on Google Classroom. We're given the 2 points, -4, 5, and -7, 10. We are asked to find the point that is directly in between them. To do that, we use the midpoint formula. This is the midpoint formula. Add your x values, divide by 2. Add your y values, divide by 2. For those who were at school before the closure period, we were reviewing how to find the median. So you might remember this process that we used when finding the median. If we add 2 numbers and divide by 2, we're finding the number that is directly in between the 2 given numbers. So for example, if we're given the 2 numbers -4 and -7 and asked to find what's directly in between them, when we add them, we get -11 dividing by 2 gets us -5.5. So -5.5 is the x value for our midpoint because it is directly in between the 2 x values for our original point. Same thing with the y. Add the y values, 5 plus 10 gets us 15, divide by 2, and we get 7.5. So 7.5 is the y coordinate for our midpoint because it is the y value that is right in between the 2 given y coordinates, 5 and 10. So our midpoint is -5.5, 7.5. That's our final answer for number 4. Stepping down to problem 6. We're still using the same format, but now I actually give you a picture so you can better visualize where the midpoint actually lies. And technically, you don't even need to use the formula to find the midpoint. So really, if you just look at the x values, so we see one x value, oh, it's backwards, is 1, and the other x value is 4. We're looking for the number right in between 1 and 4. If you're not able to do that in your head, to calculate it mathematically, you would do 1 plus 4, which gets us 5, divide by 2, and get 2.5, which we see kind of makes sense. 2.5 is right here in between 1 and 4. So the x value is 2.5. The y value, if you wanted, you could just look at the y values, which are 0 and -1. The number in between 0 and -1 is going to be -0.5. If you wanted to do it using the math, add the y's, 0 and -1, which gets you -1, divide by 2, and you get -0.5. So again, if you just look at the picture, visually you will be able to see where the midpoint is. But if you want to check your work with the math as well, that way will always work, even when we are not given a picture. On the back, we were reviewing the distance formula. So the first way we learn how to find the distance between points in the coordinate plane, or the length of a line segment in the coordinate plane, is by using the Pythagorean theorem. So the Pythagorean theorem is for a given right triangle, the A and B are the legs, and the C is the hypotenuse. A squared plus B squared is always going to be equal to C squared for a right triangle. When we're finding the length of a segment in the coordinate plane, we can construct a right triangle and use the Pythagorean theorem to find it. So the length of the segment is going to be our hypotenuse, our C. I believe this is A up here. Let me double check. Yes. So the A or B, it doesn't matter. A or B is going to be our vertical distance between the points, making a straight vertical line. And then B or A is going to be the horizontal distance between the points. So you would be creating a horizontal line. When you're given the segment in the coordinate plane, you can just count this distance. So if we count these squares, there are going to be 8 of them. If we count these squares, there will be 4 of them. So all we do is plug them into the formula. 8 squared plus 4 squared. Square those numbers. Don't add them before you square them. Make sure they are squared first. Remember, order of operations, do exponents before addition. So 8 squared gets us 64, 4 squared gets us 16. Now we're going to add 64 and 16 to get 80. To get the C by itself, because technically we have c squared equals 80 and we're looking for c, we want to take the square root of both sides. So taking the square root of both sides leaves us with c on this side. The square root of 80 is 8.94. So that means the length of this line is 8.94, which actually makes sense. It's a little bit longer than this line, right? But we know it should be a lot longer than this line down here. So our picture and our value that we calculated makes sense. Problem 12, I don't give you a picture, I just give you 2 points. When you are given 2 points, you are still using the same process involving the Pythagorean theorem. However, you have to use a more formula-based approach, usually, unless you can visualize what's going on. So we're still using the Pythagorean theorem. Our c has changed to a d because it is the distance between the 2 points, but it means the exact same thing. We're still looking for that hypotenuse, that segment that connects those 2 points. Our a, or our b, has changed to an expression x1 minus x2. x1 minus x2 is going to get us the distance between the 2 x values. Again, in the example above, we just counted that distance. But if we're not given a picture, we might have to do some math to figure it out. Or again, you could sketch a picture and visualize this distance. Our b, or a, whichever you didn't use here, is going to be the distance between the y values. So again, that was that vertical line that we drew in the picture. All we're doing is figuring out how far these 2 y values are away from each other. And we can do that mathematically with subtraction, or you can visualize it in your head, what the distance between 6 and 1 would be on the number line. Final step to just give you the formal distance formula is you would take the square root of both sides to get d by itself. So this just says the distance between these 2 points is equal to the difference between the x values squared plus the difference between the y values squared, and you take the square root of that whole process. So using the distance formula, all I did was plug in the individual values. So x1 minus x2, y1 minus y2. Again, this is just telling me how far apart the x values are, and this is just telling me how far apart the y values are. So 4 minus 8 gets us -4. 6 minus 1 gets us 5. And we're going to square these values. -4 squared gets us 16. 5 squared gets us 25. I do want to backtrack for a bit and note the fact that it doesn't matter which order you use for the formula. So instead of doing x1 minus x2 squared plus y1 minus y2 squared, you could have switched these and done x2 minus x1 squared plus y1 minus, or y2 minus y1 squared. It doesn't matter with this particular formula because the difference is going to be the same except for the sign. So if you would have done 4 minus 8, we see we get -4 squared, which is 16. If we do 8 minus 4, we would have gotten +4 squared, which is 16. And the same would follow with the y values as well. If that confuses you, just ignore it, but just don't stress about this formula too much. You're subtracting the x values and squaring it, and subtracting the y values and squaring it. Either way, you should get the same answer. So 16 plus 25 gets us 41. Taking the square root of 41 gets us 6.40. So the distance between these 2 points in the coordinate plane is going to be 6.40. Now let's look at some of the problems that were assigned in Khan Academy. So the first Khan Academy problem I had for the midpoint formula set was this one, where they gave us the points and plotted them in the plane for us. So they say point A is -1, 8, and point B is 7, 3. So they're asking us to find the midpoint of those 2 points in the coordinate plane. So here we have point A, -1, 8, and point B, 7, 3. Again, if you wanted to do it visually, we could find what value is in between 7 and -1 on the number line. It's a little easier to see it when you have the coordinate plane, so let's try to count these out. The distance from 7 to -1 is 8, because I have 7 here and 1 here. Half of 8 is 4, so 4 away from 7 and 4 away from 8 should be the midpoint. So let's see. 4 away from 7 is 1, 2, 3, 4, 3. 4 away from 8 is 1, or 4 away from -1, excuse me, is 1, 1, 2, 3, 4, 3. So we see the x value for our midpoint should be 3. If the x value is 3, all we have to do is go up to our line to see what the y value would be. So when x is 3, that y value was 5.5. So without doing any formal math or any equations, we can see that the midpoint should be 3, 5.5, which I've already entered at the bottom. But I will show you the mathematical way. So with this problem, again, we had -1, 8, and 7, 3. We want to add our x's, -1 plus 7, add our y's, 8 plus 3. -1 plus 7 is 6, 6 divided by 2 is 3. Doing the same thing with the y values, 8 plus 3 is 11, 11 divided by 2 is 5.5. So just like we saw visually on the graph, the midpoint of these two points should be 3, 5.5. As we know, Khan Academy is notorious for amping things up immediately, so they did not waste any time with this problem set. In the next problem, they give you an endpoint and a midpoint. If we went over this in class, we probably just did one example for the sake of time. This is a meaningful problem that we can figure out, and you have the tools to figure out. So let's try to figure it out visually. The endpoint they give us is A down here. Oh, there's my pen. It's here. So we have this endpoint A down here. The coordinates are -1, -9. The midpoint that they give us is 0.5, -2.5. Again, my students know how to work with decimals in the coordinate plane, so don't let it trip you up that it's not on the line. Again, this is 0.5, -2.5. To find the other endpoint, we know it has to be somewhere up here, right? Because it's a segment going straight like this. So let's try to figure out how much more we need to get to the other x value of the endpoint. If we're looking at the x values, this x value is -1, this x value is 0.5. We need to find this distance from -1 to +0.5. This distance here is 1.5 units. So again, we go 1.5 units to get to the midpoint. So to get to the x value of the endpoint, we're going to do the same thing, go 1.5 units. So again, we go half and one more. So 1.5 away from this midpoint is going to be 2. So the x value for our midpoint, for our other endpoint, should be 2. Let's do the same thing with the y values. So the distance between the y values, this distance down here, or this y value down here, is -9. This y value right here is -2.5. So we want to take the time to count the distance or figure out the distance between -9 and -2.5. So we have 1, 2, 3, 4, 5, 6.5. So 6.5 is the distance between -9 and -2.5. So we want to increase by 6.5 more. Again, we've already figured out that our x value is 2. We just want to go up 6.5 from this point. Half, 1, 2, 3, 4, 5, 6. Again, my pen might be a little unsteady, but your point should be at +2, +4. Again, it's backwards for me. So +2, +4 should be your other endpoint. If that process was a little confusing to follow visually, I did do it algebraically for you guys as well, using the same formula we've already used. Just have to step it up a notch. So again, I solved it right here. So to solve it using the formula, you have to set up two equations separately. The first equation is focusing on the x values. So keep in mind, to find the midpoint, which we are given, the x value of the midpoint is +0.5, we're going to add the x values. So our two x values are -1 and x, because we do not know what this other x value is. So we set up an equation, x1 plus x2 over 2 equals +0.5, because that is the x value of the midpoint. So again, we're doing -1 plus x over 2 equals +0.5, and we want to solve this equation for x. We talked about this, I believe, yesterday or the day before, solving multi-step or two-step equations. To isolate This x, we have to multiply both sides by 2 first because we're working backwards, reverse PEMDAS. This expression in the numerator is technically in parentheses. Let me add that. So when a fraction is written in this way, we want to isolate the parentheses first. Again, work in the opposite direction of PEMDAS. So we're going to multiply both sides by 2. 0.5 times 2 gets us 1. 2 times this expression would keep the 2 in front, but 2 divided by 2 is 1. When you have 1 times this expression is just going to come down. So again, we're left with -1 plus x equals 2. Again, an easy way to remember this is we're just canceling these 2's out. 2 divided by 2 is 1. It's canceled. It's gone. So we're left with -1 plus x equals 1. Now the last thing we do to get x by itself is add 1 to both sides, so x equals 2. For the second part of the equation, you do the exact same thing with the y values. So we're doing y1 plus y2 equals the given y value. So again, this value is given. We were able to find it from the graph. So this y value is -2.5. We'll need to figure out what are we adding to -9 and dividing by 2 to get -2.5. So we're doing -9 plus y divided by 2 equals -2.5. That's the second equation we have to solve. We solve this equation using the exact same steps. Multiply both sides by 2. We multiply by 2, the 2 in the numerator and the denominator cancel. So we're left with -9 plus y. On this side, we did -2.5 times 2, which gets us -5. Our final step to get y by itself is to add 9 to both sides to keep the equation balanced. We are adding 9 because this 9 is negative. -9 plus 9 is 0. 0 plus y is y. On this side, we get -5 plus 9 equals 4. The rest of the problems in the midpoint formula set are exactly the same as the 2 examples I did, so I'll let you guys figure those out. Again, I found it easiest to just use the picture and count the squares, but again, the formulas will work every time as well. The other set I gave for today's review was finding the distance between 2 points. We're going to take a look at some of those problems. The first example that was given to me in the problem set was finding the distance between these 2 points. So I'll admit, when I first looked at it, I thought it was just a vertical line, but we can see that they don't actually have the same x value, so there is a little bit more work involved. But because they give us a picture, we can use the Pythagorean formula, which is usually a little bit easier. So we can count the distance between the x's. The distance between the x's is 1. The distance between the y's, if you want to pause and count, should be 8. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So our a and b are 1 and 8. So we're doing 1 squared plus 8 squared equals c squared. 1 plus 64. 1 squared is 1. 8 squared is 64 equals c squared. 1 plus 64 is 65. To isolate c and get rid of this square, we take the square root of both sides. So c is equal to the square root of 65. That square shouldn't have been there. That should just be c equals the square root of 65. So that's our final answer, and that was one of the Khan Academy answers. This particular problem is asking us the same question, just in a different way. So they ask us to find the length of the line. They expect you to understand that you are still required to count the vertical distance between the y values, and the distance between the x values. If you want to pause and count, you can. Then I will show you the work I did. So for the distance between the x values, I got 10. Distance between the y values, I got 6. So I plugged them into the Pythagorean theorem. 6 squared plus 10 squared equals c squared. 6 squared is 36. 10 squared is 100. 36 plus 100 is 136. Taking the square root of both sides isolates the c. So we are left with c equals the square root of 136. And that's problem 2. The next problem switches it up on us again and just gives us 2 points with no picture. So we're going to use the distance formula for this. Keep in mind, if you're a visual learner, all you have to do is think about what the distance is between -6 and -3. I'll show you with the math and then walk back through it visually for those who don't necessarily like the formula. So we're doing -6, subtract the x's, -6 minus -3, 8 minus 9. When you're subtracting a negative, that changes to addition. We've reviewed that multiple times in class. So -6 plus 3 gets us -3 squared. 8 minus 9 gets us -1 squared. -3 squared is 9. -1 squared is 1. 9 plus 1 gets us 10. So our final answer for the distance is the square root of 10. Again, this distance formula came from the Pythagorean theorem. All we did was take the square root of both sides, change our a value to the distance in your x's, and change the b value to the difference between your y's, or the distance between your y's. If you're doing this visually, if you visualize -6 and -3 on a number line, we know that there are 3 numbers in between them. -3 to -4, -5, and then -6. That's where this 3 comes from. Again, the sign doesn't matter because we're going to square it. -3 squared and +3 squared both get us 9. So that sign is not that important. Doing the same thing with the y's, the distance between 8 and 9 is just 1. 8 to 9 is 1 jump. So again, the sign doesn't matter. -1 squared and 1 squared both get us 1. So again, if you're thinking of that visually, that's another way you could have approached this. Regardless, the final answer for this problem should be the square root of 10. Another problem in the set was very similar to this last problem we just went over, but it actually simplified. And it kind of threw me off for a minute, so I wanted to make sure that I gave you guys an example like that as well. So they give us the 2 points, -5, -5, and -9, -2. And again, we're asked to find the distance between those 2 points using the distance formula. So we go through the same process, find the distance between your x values. So the distance between -5 and -9, if we're doing that in our head, that is 4. If we're doing it mathematically, we're doing -5 minus -9, which changes to -5 plus 9, which is 4. For the y values, we're looking at the difference or the distance between -5 and -2. If we're doing that in our head, that is 3, right? We go -3, -4, -5, so it'd be 3. If you're doing it mathematically, we're doing -5 minus -2. Subtracting a negative gets us a positive. -5 plus 2 gets us -3. So we have 4 squared plus -3 squared. 4 squared is 16. -3 squared is 9. 16 plus 9 is 25. And when we actually type this into the calculator, or when we are thinking what number times itself equals 25, the answer is actually 5. So there are only a select few numbers that will give us a rational or a whole number for this answer. So the square root of 25 happens to be the whole number 5. So in Khan Academy, the answer I had to select was 5. The rest of the problems in problem set number 2 were pretty straightforward based on the examples I've shown you, so I'll let you guys figure out the rest of those. But if you have any questions about your particular problems in the set, or any of the other problems on the worksheet I did not go over, please feel free to reach out through email, text message, Google Classroom, this YouTube video, whatever you need, whatever support you need, I'm here for you. Just make sure you're reaching out if you need it. I want to end today's video by going through the daily meditation for yesterday that was posted on Google Classroom. So yesterday's daily meditation was the key to a financial blessing. Many families are struggling with their finances during this quarantine period. Although local and federal agencies are attempting to alleviate some of the economic pressures that we are currently facing, such as delaying rent and utility payments or increasing government assistance programs, I believe one of the most important things we can do with all this time we've been blessed with is make a plan for our money. I plan on using this time to create a budget. If looking at my current finances is too stressful, I will make a budget based on my situation before the quarantine. It might even be worthwhile to help other family members do the same. This is just another way to get our minds off of our current situation and be proactive in preparing for the future. Again, feel free to share your thoughts based on the daily meditation. If you just wanted to hear mine read to you, you're welcome. I thank you so much for taking the time to watch this video. Again, if you guys need anything, help with resources, help with the math, if you just want to talk about the situation, you can set up a phone call conference or Google Hangouts, Zoom, whatever you guys want. Just make sure you're reaching out if you need the help. Again, thank you for watching, and I will see you later.